Yep. So hi everyone. So we are the Autonomous Race Car group. But first, we're gonna be introducing ourselves. So first, my name is Richard Laforteza. I am the team leader and electrical engineer of the group. I've been interested in working in the field of automation technology. And after college, I plan on working in industry and applying the knowledge that I have gained.
Hi, everyone. My name is Anthony Savides. I am a senior computer engineering major. I have an interest in AI software development. So in this project, I've taken the lead on the neural network implementation and assisting with Bluetooth communications between our app and our car, which we'll get into later.
Hi, I'm Aaron Cassius. I'm also a computer engineering major. I have an interest in robotics, and my focus in the project is on our app development.
Hi everyone, my name is Abhirushi. I'm an SF engineering major. I'm focused to working for the vehicle models for race car model in MATLAB.
So what is the autonomous race car that we are creating? So we are basically designing and developing a micro race car with autonomous navigation. And with autonomous navigation, our race car should be able to go through a simulated track by itself, depending on like the terrain and basically the surroundings it's in. And with the autonomous navigation, we'll be utilizing different autonomous control. But for us, we'll be using a convolutional neural network, which will be explained furthermore.
So for our goals for our project, we want it to be able to go through a predetermined course and progressively learn its path. Here on the screen, we have the TCNJ track and field, which is our predetermined course we'd like to complete. We want it to also be remotely controlled by a user. And for the last goal, we want it to travel from a selected location to a desired destination of any kind, which is kind of our reach goal for the project. Here on the left, we have our race car. This is without our mounts printed yet, which is actually in the process right now. On the right, you can see, on the right in figure 2, you can see the microcomputing board, which is a NVIDIA Xavier NX development board, which we'll be using for the training and actually controlling the car through its motor and servo for the wheels.
Yeah. So on the right, we have the application which I have developed. It's to mimic the physical controls of an RC car, where one joystick will control the throttle and the other joystick will control the steering. The goal is to communicate it via Bluetooth to the computing board that Anthony had mentioned, and there it will send the different signals to let the user control it so we can be able to train the car.
Just to go into a little bit more detail of the process behind this, this is called a regression problem where we have an independent variable and a dependent variable. Our dependent variable is going to be our wheel value, which we're trying to predict. And dependent variable going into our model would be our images. So we use a convolutional neural network because it's really common with image recognition, and computer vision is really commonly used and efficient. So a convolutional neural network is made up of convolutional layers, which applies trainable filters to its inputs, like when you give it an image. So remember certain parts of it and key features. So once we would train our model based on, let's say, the track, which is our main goal, we would take the car. Once we put it on the track, we would have the camera take a certain frame at a certain point and compare it to inside our convolutional neural network. And inside a convolutional neural network, it'll predict that wheel value that we want, which would drive the race car all throughout the track.
Yep, and just to go a little in depth about the power system. So in order to power our whole autonomous race car, we're having two separate power distribution systems, one for our computing board and one for our drivetrain motor, just to ensure that if we were to power up our drivetrain system, it will not affect the power going to our computing board. And now we'll open up the floor for any questions about the project.
Any questions?
What the fuck is that?
I think we have. I guess not. I thought I heard a question. So what's been the biggest problem that you have had on this project?
I would say one of the main problems, or maybe the hardest part of the problem, is definitely the data collection phase, just because of how much data we have to get, and our location affecting the track. It is kind of out of range from any kind of power sources or out of any like signal ranges for like Wi-Fi. So we're kind of on our own out there on the track once we go out there. And we have to make sure that our data collection process is kind of perfect once we're there, because we can't have bad data going into our model, because then the model will not be sufficient. So I would say that would be the hardest part, the hardest process of the project, in my opinion.
And how far away are you from completing?
Right now, we are in the middle of data collection, but at the same time, we are working on our neural network implementation. So I am, like, I have created like a basic architecture and kind of got simulation data close to the track. So I don't have an exact estimate, but once we get a little more data, we are pretty close to where we want to be in the project.
Okay, I don't have any other questions. If no one has any other questions, I'll throw it open to questions for any of the projects that have gone by so far.